Okay, question number 13. A ray of light, a ray of light passes from air into a long glass plate of refractive index n at an angle theta to the edge of the plate. Okay, a ray of light is passing here, it cuts over here, and then and there are two rays here. What does it tell? Ray is incident on the internal surface of the glass plate, and the refracted ray travels along the external surface of the plate. Okay, it travels along this direction, which means what? The angle at which this is falling is your critical angle, right? Okay, and then what changes to n and what changes to theta will cause the ray to travel entirely within the plate after incidence. So how should I change the value of theta, and how should I change the value of this n here so that it reflects inside? Now definitely you see the denser medium is characterized by larger values of n. Larger the value of n, the larger the denser medium, and thus it's better that if this becomes more denser, this is become more rarer over here, total internal reflection can take place, because that is what is being the criteria which is being asked over here. It says what changes to n and theta will cause the rays to travel entirely within the plate after incidence. So he doesn't want this to get refracted back, but instead he wants this to get reflected interior like this over here. So if this has to happen, this should be a denser medium, and as long as the value of the n increases, definitely it's a good thing for us. So therefore I need to increase the value of n. So which ones are right? So which ones are wrong? These two are right and these two are incorrect. Okay. Now we need to look at the effect of theta. Let us do it like this over here. So now let me consider for time being that the value of C, critical angle, is equal to some 50 degrees over here. 50 degrees over here. Okay. And if this is 50 degrees, now let me complete this triangle. Okay. If this is 50 degrees, and let me say this value is 90. If this is 90, what should this angle be? So this should be 50 plus 90 plus r should be equal to 180. So 140, r should be equal to 180 here. 150 plus 90 is 140. 180 minus 140 should be equal to 40. So the value of r is equal to 40. I want to do something like this because to understand the effect of theta. So if this value of r is 40, what will be the value of this I? Right, this is your angle of incidence, not this one. This is the angle of incidence. So the angle of incidence would be greater than 40. Greater than 40. And what will be the value of theta? The value of theta is the same. Okay, let us say theta over here, because I want to find like the value of theta. Now what I will do is, if I say I will increase the value of C. Okay, sorry, C value cannot be increased. C value remains a constant over here until unless you are raising the value of n. There are two possibilities. Either you increase the value of n or you change the value of theta. Okay, let me consider the value of n is kept constant, C kept constant, because you know n is equal to 1 by sine C, right? So sine C is equal to 1 by n. So therefore the value of C also remains a constant. Now if suppose if I have a ray which is now incident at a larger angle here, okay, which means what? Your angle of incidence over here is like this. It's like this. If it is like this, then this would have gone somewhere over here. If this would have gone somewhere over here like this, then the value of r is increasing. Value of r, let me put this 50 over here. If the value of r is 50, then 50 plus 90 would be 140, and this value of it would be 40. This would be 40. But since the critical angle is 50, and this angle, if it is 40, that means what? The angle of incidence at this point is I2 is less than the critical angle. If it is less than critical angle, what will happen? It will not get internally reflected, but it will be externally refracted like this, right? So therefore, when you decrease this value of r, when you increase this value of r, it gets refracted. Okay, now let me write like this. If r is increased, then which also means that I is increased, because sin I is in the rarer medium. I is also increased. When I is increased, which means theta is reducing. Why theta is reducing? Because you see theta plus I is equal to 90 over here, right? Theta plus I equal to 90, which means theta should be equal to 90 minus I. If I make I is equal to 40, I get theta equal to 50, right? Let me write it down if you want. If I make I equal to 40, I get theta equal to 50. If I say I is increased, according to my logic, if I put I is equal to 50, what will happen to theta? Theta should be 40. Now, what is the purpose of doing this? If r is increasing, then there will be a refraction. But I don't want refraction. So what should I do? R should decrease. If r should decrease, what should happen to I? I should also decrease. If I should decrease, then what will happen to theta? theta will increase, right? Theta will increase. So therefore, the answer is n has to increase, theta has to increase. So answer is here. Okay. If you do not understand this, do let me know. I would like to make a separate video and show it to you how does it work. Thank you.